Hello and welcome to another video entry. My name is Maxwell and today I'm going to be talking about securing Cisco video networks. The rise of video conferencing as a preferred means of collaborations has resulted in the fact that when global video conferencing revenue projections are being calculated, it's estimated in the billions of dollars. As we all know, telepresence technologies have enjoyed a demand fueled by the allure of increased productivity and the possibility of over 60% return on investment. Hackers and other skilled individuals with malicious intent, unfortunately, are also aware of this fact. They've utilized the opportunity to prey on many companies as business executives and decision makers look to the shark-infested waters of computer networks for solutions to improving collaborations and productivity in the corporate environment. In recognition of the associated risk of video technologies, Cisco, being a market leader, has developed security mechanisms which I'll be talking about today. So I think it's probably best to start off by just talking about some of the ways that companies are being hacked today. And we're going to be demonstrating some of those methods, and we're going to be talking about possible solutions and safeguards to prevent one from being a victim of such attacks. Now, one of the primary methods that hackers use to take advantage of people's video infrastructure is by, for instance, just guessing the credentials for an endpoint. Now, that may really sound odd, but it's really simple to guess the password required for registration in a video network if that video network has been deployed with its default settings, because by default Cisco video networks are designed for quick installation and also to ensure that everything's up and running, and because every environment is bespoke, the security features are put there, but it's essentially up to the engineer to deploy those security measures and ensure that the company or the entity is sufficiently protected. So by default, video networks are extremely vulnerable, so vulnerable that it's possible to guess a password and log in by no special means, and I'll be demonstrating it today. Secondly, another method that hackers use to take advantage of people's video networks is by, for instance, sending a telephone number to the video infrastructure and getting the video infrastructure to route the call. It may be, for instance, a long distance call for the hacker, so the hacker may be sitting in the same country, for instance, and or even remotely, but they'll use free of charge IP network and send their call request over IP. The video infrastructure receives the request and forwards the call out via a SIP gateway or an ISDN gateway, and then the company then incurs the charges. That is another security flaw. So those are the two major security flaws or vulnerabilities that we're going to be looking at today, because they are the most widely used. But however, just to mention another one, some hackers also seek to register to company networks by just pretending to be part of the domain. Another slight variation to that is that some hackers may send a telephone number in the URI format and add the official domain of the video network as the domain section. So they will have a telephone number at, for instance, cisco.com in a bid to try and fool the video infrastructure to thinking that this is actually a call for the video estate, and then somehow, if the video estate has not been secured properly, the video estate will then strip off the domain and then route the telephone number, and then the call will then connect to the remote party, all free of charge for the hacker. Apart from that, I mentioned that it's possible to easily guess the credentials for logging onto a video estate, and of course we do know that in video networks there is such a thing called far end camera control. What this essentially means is that I could log into a network with a video endpoint, and I could dial a remote device, and if that device happens to have, for instance, auto answer, let's say it's a boardroom, or any video endpoint within the company, if that device happens to have auto answer, once that device answers the call, I could then choose to control the camera of that endpoint. Now, just think about how strange or how frightening it sounds for a hacker to be behind a remote video endpoint controlling the cameras within the company. That itself is a major security risk. It's like having surveillance of a company that you're not even remotely associated with. That could be potentially disastrous. So some of those things are all the things we're going to be looking at today. We must, I think, but before we go into that, now that we've stated our objectives, let's talk about the devices that I have deployed in this video estate for this demonstration. So I'm going to go into the VMware infrastructure. I've got an Active Directory server, which is where I'm pulling all the user database base from the list of users that I'm going to be assigning access to the video estate. So it's assumed that the users are part of my Active Directory. So I'm just going to use that for simplicity, use that same directory to just pull users. In addition to that, as we know, I've got my Expressway E and Expressway C, but actually it's VCS C and VCS E. And if we go back to this diagram, we can see here the VCS control, which is the C, and the VCS Expressway, which is the E, which resides outside of the firewall. It's essentially the twin pair of servers that enable our firewall traversal. And we'll scroll further down. We've also got a telepresence management suite, which I'm using to provision users, provision their endpoints that I'm going to be assigning to them. And of course, I've got other Windows devices that I'm using for running telepresence, so Jabber for telepresence. Okay, so we talked about the first vulnerability, the ability to guess a password and just log into the video estate easily. It sounds really strange, but do not doubt me, a lot of video networks are set up like this, and we're going to prove it. Okay, so I'll start off by going into my VCS control. Okay, just going to quickly go into my registrations. I can see several devices registered to me there. Okay, so I'll just pop back out, and then this is one of the devices here, Jabber for telepresence, which is currently in a call with another user called Jack Bat, and this is Dr. Brown. So what I'm going to do is, first of all, I'm just going to log out Jack Bat. Logged him out. I've told him to remember. I've told the Jabber for telepresence to remember the password. But now if we take a rough, I'll just log back in. So we can take a note of that password length. I'll sign in. Okay. I'll sign back out, and then I'll log out. Just one digit. I'm still signed in. So that means the password means absolutely nothing. That is what it essentially means. What this then means that so long as I have the user ID, I can log onto this video network. Sadly, a lot of networks are like this. And how is this possible? And how is it easy? How easy is it for a hacker to guess the user ID of an individual within the company? Now, for instance, I could go to companieshouse.com and get the list of CEOs, the secretary, some maybe members of the finance department. Companieshouse.com, I could get the company listing and the individuals. I can get the first and second name, This is all public information. I could go to the company's website, get a list of directors. These are the kind of people that are more likely to be utilized in the video networks. So all I have to determine is, in their company network, when they're logging into Active Directory, do they log in with first name dot last name? There's always a format to user IDs in any given infrastructure, unless of course they're using company numbers. But let's say they're using their names. Now, this is standard deployment of Telepresence Management Suite, the server used for provisioning endpoints to users. Now, I have provisioned users from my Active Directory, and what I have here, I'm using a format of, this is a variable that says take the username and add at labs.com. Use that to form the video address. Also use the username section to form the login credential. So I'm pulling this straight from Active Directory. Now, of course, that is very easy to guess. If you work within a company and you know your domain login credentials and you know your first and last name, if you know your colleague's first and last name as well, you should be able to guess what their user ID is. It's really that simple. So, we now know how easy it is to just log in and get user details. Now let's confirm this. Let's just quickly look here. Okay. So this is the TMS, Telepresence Provisioning Extension Services, Telepresence Management Suite Provisioning Extension Services, and we'll just go down and look for all the users we've pulled from TMS into VCS. Go into the details. And we can see two active users. We can see their user IDs, D Brown and Jack Bat, which is JBat. So that is the general format. This is all that would be required to guess someone's user ID and log on, and from there start making calls. So that's problem number one. Now here is another slight problem, which should be a worry to everyone else. I'm just going to quickly do something now. Let's pull up Wireshark. And then let's sign out. Let's sign back in. So now we've signed back in. Now we can see some SIP messages. Just for your information, the .15 address is the address of this computer, and the .23 is the address of the VCS control. So just from this, we can see that there's back and forth communication between the endpoint and the video communication server. But here's what's interesting. We see here a signal we see here a signal from the endpoint to the VCS requesting to subscribe to the domain, and it said that its name is dbrown@labs.com, which is right, and go there, it's dbrown, and the system said okay, and then subsequently the system has come back to it and sent this zip/XML response. Now what this implies is that there is an XML document attached to the body of this message. Now let's see what's contained in that body, and that for me is what I think is quite risky. I really do believe that regardless of how little the information is, we really shouldn't be sharing it with people who don't have the right privileges to be in possession of that information. Now, this is a provisioning response. The XML file is a provisioning response, and if you want to understand what provisioning means in the world of video, it's similar to IP telephony, where a phone registers to tries to connect to the network, and first of all sends a configuration file request to the TFTP server, and the TFTP server responds back to with a lot of privileged information, like the internal IP addresses of all the core managers and so on and so forth, and what the servers are doing, blah blah blah, and so on and so forth. So similar thing we have here. If we just minimize this and go to the message body, we can see the XML file. Here it's telling about things like bandwidth, how much bandwidth it has to the ability to use. It's telling about its encryption, what kind of encryption should it be using. It's giving the name of the VCSC server. It's giving it its device name, and so on and so forth. So it's just basically giving it a lot of privileged information that we don't even want to be sharing. We don't even want to think of what a hacker can do with it, because the smallest information is more than sufficient for a good hacker. So that's another thing we want to take care of. We've got signaling in wide open, potentially media also in the open air, just being shared. So we want to take care of that as well within this video series, or preferably in this particular video entry. So we're going to move on to the final thing. Now we've talked about being able to register into the network. We've talked about being able to make random calls once you're registered to the network. We've talked about having the signaling exposed for anyone to view and gain a deeper understanding of our network, and from there even launch further investigations. Now we need to talk about a device that is not even registered to the network, that is able to forward a call to us and have us send it to our SIP gateway or ISDN gateway or a call manager. Because, for instance, just as we all know, in most deployments we attach to this VCS control, we might have call managers sitting here, and we have a SIP trunk, and so we can forward regular IP telephony calls to call manager. Now if someone here is able to send a call, a long distance call, all the way through here down to call manager, then we establish that call for them. There might be, now there could be legitimate reasons why we want to give legitimate users the ability to dial long distance telephone calls from their video endpoint. There's no reason why they can't do that. But we don't want to give that same privileges to external parties or external hackers that are not actually part of our domain nor registered to our domain. So how do we do that? But before we do that, let's demonstrate the problem. So I'll go into search rules, and I'll go into configuration, dial plan, then I'll go into search rules, which are similar to route patterns or dial pairs in the IP telephony world. So we've got here a rule that says that anything that starts with, I'll zoom into that. We've got a rule here that states that anything that starts with a 9 followed by star will be matched here, and we'll forward it down to the local zone. I've just used local zone because this is a lab environment and this is for demonstration purposes. It could be a neighbor zone, and the neighbor could be a call manager, it could be an ISDN gateway, it could be anything. Just anything capable of forwarding that call on. So here I basically said, let me zoom out a bit. So what I basically said here is, just for demonstration purposes, this is the number that will be dialed. This is the regular expression that will be matched. Anything started with 9. We're going to change it to jackbat just for demonstration purposes. But we could just choose to come here and say leave and just forward it on as it was originally dialed. So is it possible for anyone to dial this? Absolutely. If, for instance, as we had before, we're within, because anyone can log in, we have let's go open that rule again. So 9, anything that starts with 9. So let's come here and let's say, let's pick up this guy who is not registered to our network. He's not a member of our network, just to show you. His name is Hacker2 and he's from a domain called hacks.com. Our domain, let's open our domain so we know that we're in a completely different domain. Our domain is labs.com, so it's a completely different domain. So he's not registered to us, but he's able to make calls. And so he sends a call to us, and this is the number he dials. Able to call it. So he was able to make that call. Now, if you look at that number, let's go to the call history. That number started with 9. In a corporate environment, 9 is for outside line, then 00, 0 is for international call, and then 1, which is for the USA. So someone's just dialed us, got us to make a call for them to the United States of America, and we're going to pay the premium for that. So how do we prevent all of this? So the very first thing we're going to do is we're going to enable security. We're going to say 1. We're going to create a connection to our Active Directory server. We're going to use our Active Directory as our authentication source. And then we're going to say that for certain telephone numbers, if you have not previously supplied credentials, valid credentials, you will not be able to 1, register to our network, 2, call numbers that we don't permit you to call. We will permit you to call internal users, but will not permit you to make international calls or calls which we call privileged calls. So in order to start that, the very first thing we're going to do, we're going to go to authentication. We're going to go to configuration authentication, devices for device authentication. On the device authentication mechanisms, we have various mechanisms you can use. We've got local database. We will just put username and password into the local database of the VCS. But we want to make sure that users can just put in their normal AD credentials. We're going to go to Active Directory. The assumption is that this is a SIP deployment, SIP network. And let's say we turn this off. This is how we'd find it. And then we'd come here, turn on our connection to Active Directory. NTLM protocol challenge for devices that support NTLM. They will be authenticating via that means, or they'll use digest method as listed here. I'm going to set that to auto. I'm going to put my domain name, the domain that my Active Directory server belongs to. I'm going to put the NetBIOS name. I'm going to set the secure channel to auto and encryption to off. I could actually upload the certificate and put it to encrypt it, but on this occasion I'm not. The assumption is that this VCS VCS control is in the internal network. However, in real deployment, best practice would be to enable that TLS, but on this occasion we're not. What's most important here is the clock skew. I would recommend following 300 milliseconds, otherwise one may become open to relay attacks. This is purely for lab environment, so putting this figure in the real world is really asking for trouble. You want to put the default in, which is represented here. I believe that is approximately 5 minutes. Okay, we'll scroll down a bit, and I'm saying, well, I don't actually know the IP address of my domain controller, so how am I going to connect to domain controllers? In fact, I could have multiple domain controllers. So what I'm using here, what I've said here is use DNS service record to look up the domain controller. I'm saying yes. So long as this VCS control knows the domain, it would send an SRV request out via DNS and automatically find the IP address of the domain controller. That's what that implies there. Because I'm actually going to join the VCS control to the domain, I'll put my administration password for the AD, username and password in here. As you can see, it's not stored here in the actual GUI. it's only used for one-time authentication and logging into the network. So once I press save, I save that. What I then find is I can see that that status is active. It's automatically joined the domain and it's found the IP address and everything is active. So I now have a connection to the AD. So that means when I could then use AD as my authentication source. Given that, we now need to ensure, but now that we've put this in, let's do something again. Let's log out and let's reduce this to 1 character. We're still registered. The reason is this. If we come back to Cisco's official documentation here, it talks about zones or logical demarcations within our video network. We use those demarcations to determine who are external users, internal users, registered users, etc. And we may configure different policies depending on the source of a signal or a call request. So if we take a look at this, the very first rule says registration authentication is controlled by a zone called the default subzone. It says initial provisioning, which is when the endpoint is requesting for its configuration file. Initial provisioning subscription request authentication is controlled by the default zone. It goes on to say call, presence, phone book request authentication is controlled by the default zone, subzone. It says or by the default zone if the endpoint is not registered. So that means all devices that are not registered to our network are controlled by a zone called the default zone, where everyone defaults to. Okay, here is a diagrammatic representation of that logical demarcation. We can see a registered endpoint and a non-registered endpoint. Now you might want to say it's logical, so how does the video network determine what is part of the default zone and what is not part of the default zone? I'll be demonstrating that shortly, but in order to do that we actually need to look at some of the traces to give us a better understanding. But at this point it's just good for us to understand that we've got the default zone and the default subzone. So we see here on registered endpoint speaking to the default zone and registered endpoint speaking to the default subzone. Okay, we come back to our zone configuration and then we go to actually let's do something to give us a clear understanding. So we now know what all the problems are. Let's talk about resolution. But so we can have an understanding of what we had prior to the changes we're about to make, let's look at some SIP traces. So let's actually see what's going on in the background. So I'm gonna make a call. Okay, I'm gonna stop that call. Now, before I press the cancel, these were the 3 messages. Take note of this. We had an invite, which is a request from the endpoint to the VCS saying I want to make a call to this number. Then we had a message saying then we had a response back saying, okay, I'm trying to make that call for you. And then we had a ringing message. Okay, so we'll cancel that, refresh that, and then let's do the next thing. Let's log out the video endpoint with the improper password. Now let's log him in. Let's see what happens. So once again, we see a subscription request. We see a 200 OK message, which means okay, I'm happy with that. We see the configurations being sent from the VCS endpoint, the VCS video communication server to the endpoint. We see the endpoint acknowledging that, say, okay, I'm happy with that, thanks for the configuration. Then we see the endpoint sending a register message, say, okay, now they've given me the configurations, I'm now going to register to the network. And then we see the endpoint say, okay, I'm happy with you registering, so on and so forth. And then we see a publish as well, which is basically just talking about, you know, presence information. So that's irrelevant there. Okay, so now we see the trend. We did not see anything at all said, any headers here that said anything about authentication or password. We did not see anything about that. So it's good for us to take note of those two scenarios. Now let's go back to VCS control. And the very first thing we're going to do is, now that we know that unregistered endpoints use the default zone to send calls in, we know that this endpoint is an unregistered endpoint. So we know the place we need to go to block this device from making unauthorized calls and so on and so forth is the default zone. We know the place we need to go to stop an endpoint from registering and getting information like our provisioning information that we shouldn't be sharing. We know the place to block these kind of endpoints, these rogue endpoints, is at the default zone. That is the logical location. So we go here, dial plan, and we go to, zones, and we go to zones. And go to default zone. And then we say, previously default was treat as authenticated, hence the reason why anyone could just log in as they pleased. Now we say check credentials, and of course the credentials that is going to be checking, how is it going to check the credentials? It's going to use it by all the methods listed here. It's going to try all possible methods listed here. So we've done that. Now let's see what happens. Let's do the same. Okay, so we've put the rule here that says you must check credentials here on the default zone. That is where unregistered endpoints go to. Let's go back to this document and check one more thing that was mentioned. It says calls. In fact, that's the only thing I want us to focus on. Calls is controlled by the default subzone if the endpoint is registered, our endpoint is not, or by the default zone if the endpoint is not registered. So does this imply that this endpoint will not be able to make calls because this endpoint here is not part of our domain? It's a domain, its domain is hacks.com. It does not have any username or password as displayed here. It doesn't have a password, so we don't have that user on our network, so it won't be able to register to our network. In fact, we're not telling it to register to our network, we're just sending it to send request here. But does that mean that because we've put check credentials on these domains, because it doesn't have credentials, we won't be able to make calls? Absolutely not. And how is that the case? We'll find out in a second. But let's first of all test that it does not need credentials to still make a call. How do we prove that? Put jbat, we tell it to call jackbat. Why? Because jackbat is a valid user. We have not configured anywhere that it can't call jackbat. But what we did mention is we didn't want external users being able to dial, for instance, anything starting with 9, because in a corporate environment, when you press 9, you're saying you want to make an outside call. Or sometimes when you press 0, you're getting a secondary dial tone. So we want to prevent this individual from being able to make that call. We just tested he is able to call jackbat. And if we look at the traces for that, if I just refresh that, refresh the Wireshark, and look for Jackbat. We see that there was no request for authentication anywhere. Okay. Now let's go to our search rules. The rule that would give it the opportunity to make an outside call. Let's go take a look at that rule. Okay, so we've got a rule here that says anything, if I zoom into that, okay, we've got a rule here that says anything that begins with a 9 followed by any other digit, we're going to send it to local zone. It could be a neighbor zone with a call manager or an ISDN gateway at the other end. But the thing is, we're saying anything that starts with a 9, you can make that call. But now we're going to do something differently. We're going to come here and we're going to say, zoom back out. Actually, let me remain zoomed in. We're going to come here and we're going to say, if the source of this call, yeah, if the source of this call is, we name it, we were told that unregistered endpoints come in via the default zone. So we say if the source of the call is from default zone, okay, if it wants to make the call, we're going to say, let's leave it like this for now, so we can actually see everything. Okay. Let me zoom back out. Okay, so we're saying if it's from default subzone, what we're gonna do is we're gonna actually gonna let it make the call. Okay, that's what we're gonna do for now. Okay, let me look for any other thing that might have a 9 in front of it. Okay, this one has a 9 in front of it. I'm gonna disable it from now. So what we said there, that rule is only applicable if that rule here, we're saying it's only applicable if it comes from a default zone. Now we've been told from this document that if you're registered, you are going to be coming from, if you're registered, your call request will be coming from the default subzone, which is written here. But if you're not registered, you're going to be coming from the default zone. Let's check that if that is a valid statement. So we go into our call history and we'll make that same call that you made previously. Okay, but let's go into Dr. Brown. Okay, so I just copied that call. So I'm going to paste it into Dr. Brown's phone. I'm going to get Dr. Brown to make the call. The call failed. Why? Because Dr. Brown is in another location. Now we know that we are able to fail a call just by saying where is it from. So on the flip side, we can also get the remote party, prevent the remote party from making that call. So I'm going to come back here. I'm going to say one. I'm going to say the zone. First, I'm going to say the zone is for all zones. We can see here, all zones is locally registered devices plus enable and traversal devices. So we're going to go there. I'm going to save. Okay. Now that we're going to go back to the endpoint, I'm going to go to the history. He previously couldn't make the call. Okay. So we've learned something there. We'll come back to our video endpoint. But what's really crucial is what I want us to see now. Okay. All right. So basically, just said I don't know that address because it's registered. The 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 video communication server has understood that this device is not a registered device. It is understood that this device hitherto now has not authenticated with the device, is or hitherto now it is not registered with the network. So clearly this must be a device that isn't part of this network, and as a result should not able to make a call. You should not be able to make that call because that call is for authenticated devices. Now, we also mentioned that one of the ways that hackers seek to hack a network is by pretending to be part of the domain. So let's say this user says that his name is hack2@labs.com. So we'll put that in there. And then he tries to call jbat@labs.com, which he is actually able to dial because we tested that previously. I'll make that call. Okay, let's restart that. And we're going to see the authentication request that I was talking about. So jbat@labs.com. Take a look at what happened here. So we see it said, hey, you say you want to call jbat@labs.com. If I'll double click that, we can see that it was to jbat@labs.com, and it was from hacker2@labs.com. So the system is clever enough to say, okay, this device is trying to tell me that he's part of my network. So okay, if that is the case, hey, proxy authentication required. And of course, it's failed authentication, hence the reason why I couldn't make the call. So the system is basically saying, because you've tried to pretend as if you're part of my domain and you're not, I won't even allow you to make a call. So it's a very, very strict policy. If we come back here, and if we put that domain back, we call jbat. Right, let's see what happened. 44 not found. All right. I just saw jbat@labs.com. I should have put in, not lab, labs.com. Okay, so now we've seen that it was supposed to be, it was just a typo. So we've learned what we can and can't, what we can do to secure our network now. So we've been able to lock down who can register. We've been able to prevent users from being able to dial numbers that they do not have privileges to dial, or numbers that we do not desire for them to dial. And of course, One more thing, we must make sure that this authenticated user can dial those extensions, so 001, and but he can't. So if we go to history, okay, so we look for, yep, any long distance number. So we've applied the rule selectively. So we've secured our network from that perspective. Our signaling is still out in the open, but that's going to be the last thing we do. Now, the reason why I started with VCS control was because I wanted to create a situation whereby, because I know some people just have VCS control, don't have expressway, and use everything solely for control. And we must not always think that our hacker, someone who's trying to hack our network, is from the outside network. We have to think about, people also trying to hack our network from the internal network. So the plan is to harden our network from the C and then extend that same uh, um, security mechanism outside. So the method we're going to be using today is called delegated authentication. So we're going to delegate our VCS control. So just to show you what I'm talking about, so we have our VCS expressway on the outside or on the DMZ, and we have our control, which we've been working on so far on the internal. Now we've been able to use that to ensure that each device logs in with the correct credentials as listed in Active Directory. So what we can do when a registration request or a provisioning request comes into the expressway from an external user or an external caller, or even if it's just a call request, we would get the VCS expressway to delegate. We'll get the VCS to delegate that tasks to the VCSC. So what we'll basically do is we'll forward that authentication request to the C. The benefit of that is that our expressway is not actually speaking directly from the outside or the DMZ with our internal AD servers, because we would get this VCS control, which is behind the firewall, to do that checking for us. How do we go about doing that? So in order to do that, the very first thing we're going to do is going to start from the C. And one of the prerequisites was that we set up the what's it called, the domains, which were already done. The domain that will be responsible for handling delegations, or the domains which this VCSC will accept delegations for, needs to be configured. The VCSC needs to think that this domain is part of my domain, because as we demonstrated before, when the rogue entity immediately tried to present itself as part of the domain by appending by appending the domain name at labs.com to itself, to its ID, the VCS control immediately kicked into overload and started saying, okay, I want to authenticate you, you claim to be part of my domain. So similarly, when an authentication request comes into the VCSC, the domain that request is claiming to be for must be a domain that the VCS control recognizes as part of the domain which it is an authority for. Hence the reason why, if we go into our configurations and we go to domains, and we can see labs.com is being configured as domain. So if a device comes in saying, oh, I'm this entity at labs.com, and I've been forwarded from the expressway E, blah blah blah, the system would authenticate them. So we created our domain. That's the very first thing, which is just create a domain there, put labs.com, save. And the very first thing we need to do, we've configured our authentication mechanism, which was our sorry authentication mechanism, devices, Active Directory. We've got Active Directory running and we're connected. So we're going to be using AD for authentication. We need to go into now SIP. We're going to go into the actual protocol. And first, I'm going to come back and turn on TLS mode, because TLS needs to be. I need to turn on CLS on protocol, because TLS actually is even required for the traversal client and traversal server. If you watched my previous video entry on mobile and remote access, then you probably have all the steps required for enabling the service certificates, and also all the required steps for configuring the traversal zone. The configs are not exactly the same, but to a very large extent. If you can do it for the Expressway, you can definitely do it for this one. In fact, it's the same server that I'm using, it's the same certificates that were on the server that I'm still using. There's been a few slight modifications to the traversal zone configurations, which I'll be sharing shortly. So I'll turn on the TLS mode, and then I'll save that. And of course, I've got delegated credential check-in. So I've done that. So now, because as we said, the authentication request is going to be forwarded from the Expressway E to C. Is going to be coming in via this traversal zone. So the next step is the traversal zone. Go to zones and go to traversal zone. You can see they've got TLS verify mode on. We've got false encryption on, and here we've got credential check-in policy. We've got check the credentials. And so those are the prerequisite configurations for the Expressway C. And of course, we must have this accept delegated credential credential checks. So when it will be accepting it via this traversal zone from the traversal server. Okay, so everything is done here, because it was already checking credentials. It knows how to do that for internal users. Now it's just saying, if someone asks, if the Expressway E asks me to do it for it, you know, will I accept? And we just said yes. So now we go to the Expressway VCS Expressway and go to the login page. Okay, I'm gonna go to ensure that my TLS is on. Okay, delegated credential check-in is also on, and from that same page is giving us a shortcut to SIP domains. It's the same thing as going into configurations domains, but here is basically telling us, do we want to configure SIP domains? Of course we do. And then we're saying, okay, we'll create one SIP domain. What we're essentially saying is this: by this configuration, we are saying that if a device comes in, let's say for instance, let's go back into this Wireshark, and we'll see a publish request here. No, let's go to actually, I'll create a fresh one. Okay. Okay, so the system, okay, the default is, okay, bear with me. Okay, good. So like for instance here we see a request coming in. I'll quickly do something. Okay, good. We can see here that when we sent in our request, if I open this, we can see here is the SIP. We can look at the SIP header here. We can see here it's saying we can see our device here saying our device trying to register and saying my name is dbrown.movi@labs.com. So which is how as we've set it up. So it's actually trying to register to our network is at labs.com. So this is what I'm trying to say here when we say we configure domains. So now that signal has come in and said the device is at labs.com. So what we're essentially saying here for domains, any device looking to authenticate with us and it's saying its name is at domain.com, at labs.com, or resides at labs.com, which we've configured here, we're saying we're going to use the traversal zone for delegated credential checking. So we pick a zone here and say send it to the expressway C. So that's what we're doing there. We're actually saying send it to expressway C. We save that, and if we go back here again, we see under NTLM configurations, we can see here we've not configured any Active Directory services because that is being managed by the expressway C. Now let's do one final thing. We said we also want to hide our encryption. Let's go into, we want to hide our signaling via TLS and even possibly media. So if we go to telepresence management services, we go to the C and we go to provisioning services. Okay, and we're going there and we'll say we'll look for users, and we've got 2 active users, but that's not the most important thing. We're going to go into the templates that those users are using. And if we go into the template, I created a template in my TMS called Jabber for telepresence template, which has been pulled by the VCS control from TMS. And we can see here that under encryption policy, we're saying force TCP and force no secure RTP. So we're going to go back to our TMS just for a template. So if anyone even accidentally guesses anything, it still has to be encrypted. Well, it kind of defeats the objective, but at least we're just saying if you're going to log into our network, please, you've got to be, you know, encrypted. So I'm going to first of all start by logging out my users. Okay, he's already logged out because I changed some policies and the system kicked him out because upon subsequent registration he was kicked out. Okay, so I'll come in here and just edit that template, and then under encryption I'm going to say force TLS, force secure RTP. Okay, alright, so save that. I'm going to quickly rush over to my TMS provision extension and we'll quickly do a sync. I'm going to quickly log in, do a refresh. Users, let me check if the template has been updated. Yes, so the devices should now try to force TLS. Let's go back. I think it's D Brown. Let's go back and check his provisioning data. Okay, that has taken effect. We'll sign out, go into video settings, go into the other server and do the same. Okay, so it's logged in. I'm going to go to the Expressway E. You can see both devices are now successfully registered to the video endpoint. So essentially, that concludes the entry for today. I will be talking about other security mechanisms and of course other authentication methods at a later date. Thanks for your time and have a lovely Christmas in advance. Thanks. Bye.